Hello everyone, I am Anas Sheikh, and in this video we will explore the lifelines keeping our digital world secure, that is advanced backup and recovery mechanisms in modern database systems. Modern applications fundamentally depend on database systems as their primary data infrastructure. Any disruption or loss of this data can have severe operational and financial consequences across industries. There are four primary causes of data loss that backup systems must address. First, system failures, including server crashes and software faults. Second, cyber attacks, particularly ransomware and malicious deletions. Third, hardware malfunctions, storage device failures and network outages. Fourth, human errors, accidental deletions or misconfigurations. Effective backup and recovery mechanisms provide three critical benefits, that is, data durability. It ensures information persists despite failures. Second, business continuity. It maintains operations during disruptions. Third, regulatory compliance, meeting legal data retention requirements. Modern database systems demand advanced backup and recovery solutions to address five critical requirements. First, compliance. Strict regulations like GDPR and HIPAA mandate enforceable data protection measures with penalties up to 20 million euros or 4% of global revenue for violations. These laws require organizations to maintain verifiable backup copies and demonstrate recovery capabilities during audits. Second is security threat and ransomware. Cyber criminals now specifically target backup systems, with 73% of ransomware attacks attempting to corrupt or delete backups. Advanced solution must incorporate immutable storage and air-gapped backups to prevent tampering. Third, distributed and cloud infrastructure. As 85% of enterprises adopt hybrid cloud architecture, backup systems must synchronize data across on-premises servers, multiple cloud providers, and edge locations while maintaining consistency. Need for high availability. Mission critical systems now require 99% uptime, pushing recovery time objectives below 50 minutes for 62% of organizations. Traditionally, daily backups and cannot meet these thresholds. Exploding data volumes. With global data projected to grow 27% annually, legacy systems fail to handle. First, petabyte scale backups. Second, sub 8 hours backup windows. Third, cost effective long term retention. These challenges render basic backup tools obsolete, necessitating solutions with automated compliance reporting, ransomware resistant design, cloud native scalability, near zero RTOs, and intelligent data tiering. Let's see modern backup techniques. First, snapshot technology. Modern snapshot implementation have evolved into sophisticated data protection tools that operate at the storage array level. Unlike traditional backups, snapshot capture the exact state of a system at a given moment by tracking changed logs rather than copying entire dataset. Second, continuous data protection. CDP systems represents the gold standard for mission critical data protection by maintaining a continuous journal of every write operation. This byte level tracking enables restoration to any precise millisecond before data corruption or loss occurred, a capability particularly valuable for financial systems and high transaction databases. Third, incremental forever backups. This methodology revolutionizes traditional backup approaches by maintaining just one initial full backup supplemented by an infinite series of incrementals. Advanced block level tracking and deduplication ensure each incremental only captures changed data segments, typically reducing storage requirements by 70 to 80% compared to weekly full backups. Fourth, log based backups. Database transaction logs provide a natural foundation for granular recovery capabilities. Modern log based solutions continuously capture and archive transaction records, enabling point in time recovery without requiring full database backups. Fifth, cloud integrated protection. Today's hybrid environment demand backup solutions that seamlessly span on-premises infrastructure and cloud platforms. Modern cloud integrated system automatically tier backup data based on policies, keeping recent restore points on high performance local storage while archiving older versions to cost effective cloud object storage. Now let's explore cloud native backup solutions, a critical advancement in modern database protection. First, we have automated snapshots. These are scheduled backups that capture the entire state of a database at regular intervals. This automation reduces manual effort and ensures consistent recovery points without human error. Next is backup storage, which is managed and scalable. Cloud platforms like AWS, Azure, and Google Cloud automatically allocate secure, redundant storage to keep backups available and durable, often across multiple zones or regions. Encryption plays a vital role in securing backup data both at rest and in transit. All three major platforms enforce encryption using strong algorithms and offer support customer managed keys for added control. Automated restore process is another critical feature. In case of failure, database can be restored quickly to previous snapshots with minimal configuration, reducing downtime and enabling faster recovery. Finally, these solutions are designed to protect the database instance itself, ensuring that critical data is recoverable, compliant, and highly available in cloud native environments. When data loss happens, whether due to a system crash or human error or cyber attack, the ability to recover quickly and accurately is vital. Modern database systems rely on a variety of recovery mechanisms to ensure data integrity and minimize downtime. First is point in time recovery. This method allows us to restore a database to a specific moment down to the second just before an unwanted change or failure occurred. It's particularly useful for recovering from human errors or malicious activity. Next is log based recovery, which relies on transaction logs. These logs track every change made to the database. In case of a crash, the system can replay committed transaction or roll back uncommitted ones to return the database to a consistent state. Snapshot recovery involves restoring the database from a snapshot, a complete image of a database at a specific point in time. This is fast and simple, ideal for quick rollbacks after system errors or upgrades. We also have full and incremental recovery. A full recovery restores everything from a complete backup, while an incremental recovery restores only the changes since the last backup, saving the time and storage. Finally, AI assisted or automated recovery is an emerging solution. These systems use machine learning to detect anomalies, predict failures, and trigger recovery actions automatically. They reduce human intervention and improve recovery speed and accuracy. Together, these mechanisms form a layered and flexible approach to a database resilience. While backup and recovery mechanisms are essential, they come with their own set of challenges and considerations that organizations must carefully manage. The first is data consistency issue. In system handling large volume of concurrent transactions, ensuring that backup captures a consistent state of a data can be tricky, especially in distributed environments. Next is recovery time and downtime. The speed of recovery directly impacts business continuity. Slow recovery process can lead to extended service outages and productivity losses. Cost overhead is another significant concern. Storing frequent backups, especially full backups or snapshots across multiple regions, can become expensive over time, particularly for organizations with large dataset. Then we have security risk. Backup data is a prime target for cyber attacks. If not encrypted or securely stored, backups can expose sensitive information and lead to compliance violations. Configuration complexity also plays a role. Managing backups, schedules, storage policies, and retention rules across hybrid or multi cloud steps can be technically demanding and error prone. Lastly, testing neglect is a common pitfall. Backups are often created but not regularly tested, leading to unpleasant surprises when a restore is actually needed. These challenges highlight the importance of not just implementing backup solutions but also maintaining and evaluating them continuously to ensure they are effective when it matters most. Thank you very much for your attention.